What if time could stretch, bend, or vanish into darkness? What if survival meant defying gravity and rewriting the rules of physics? This is not just a story. This is Interstellar, fully unraveled. Join us on SYNRIX.
A black hole spinning at nearly the speed of light, planets orbiting so close that time itself bends. 1 hour equals 7 years. Sounds like science fiction, and yet it's all based on real physics. In 2014, Interstellar took us to the edge of a dying Earth and far beyond into a cosmic system ruled by a monstrous black hole, Gargantua. A system where each planet presented a new law of nature. From Miller's world of time dilation to Mann's icy deception and Edmunds' potential new Earth. This system explored in Interstellar is anything but ordinary. It's not built around a star, but around a supermassive black hole named Gargantua. It is so massive, estimated at 100 million solar masses, compressed into a sphere just larger than Earth. Orbiting Gargantua are 3 key planets: Miller, Mann, and Edmunds. Although the system contains 2 major gravitational centers, Gargantua itself and a distant neutron star codenamed Pantagruel, a faint light source but massive enough to host its own planet, Edmunds. Interstellar didn't just invent random alien worlds. Each one explores a different extreme of physics, from relativity to atmospheric collapse and to planetary habitability. Miller's planet shows what happens near the event horizon of a black hole, where time runs differently and minutes become years. Mann's planet explores the dangers of a world that looks Earth-like from orbit, but hides a dead, pressurized wasteland beneath. And Edmunds, the only candidate that might sustain human life. Miller's planet is unlike anything we've imagined, a world orbiting just outside the event horizon of a supermassive black hole. For every hour spent on the surface, 7 years pass in orbit. It's not science fiction, it's Einstein's general relativity brought to life. Gargantua spins at nearly the speed of light. This spin stabilizes orbits in the so-called ergosphere, allowing objects to exist without immediately falling in. Due to Miller's proximity to Gargantua, the planet experiences a gravitational pull roughly equal to Earth's gravity. Miller's ocean is shallow, yet the gravity from Gargantua drives extreme weather phenomena, including colossal planet-wide tsunamis, creating waves as tall as a mountain. And because the planet is tidally locked, those waves circle endlessly, a wall of water always chasing us. Worse still, the planet's time dilation turns a brief delay into decades lost. It goes without saying that Miller's planet is utterly inhospitable. The relentless waves, crushing pressure, and extreme gravitational forces render it a hellish world, entirely unsuitable for any form of life as we know it. Mann's planet is a frozen, high-pressure world orbiting close to Gargantua. From orbit, it appears coated in ice, a reflective shell stretched across the planet's surface. The atmosphere is dense and toxic, likely composed of ammonia, methane, and nitrogen. Surface temperatures remain far below freezing, estimated around -130 degrees Celsius or lower, with no signs of liquid water or geological heat. What appears to be clouds in the film are, in fact, massive horizontal ice sheets. They are stationary layers of solid ice forming part of a layered, fractured crust. Gravity on Mann's planet is approximately 0.8 g, making movement similar to Earth, but the terrain is treacherous. There is no magnetosphere, no radiation shielding, and no energy source strong enough to sustain life. Below the outer crust, the planet likely hosts frozen mantle of water-ammonia mixtures and possibly, if geologic activity once existed, a solid rocky core. And finally, the Edmunds planet, a world untouched, unspoiled, and potentially our last hope. Edmunds' planet orbits a distant neutron star that itself is gravitationally bound to Gargantua. That makes this a hierarchical triple system: a black hole, a neutron star, and a rocky planet. An astronomically rare configuration, but not physically impossible. Edmunds is much farther from Gargantua. That distance dramatically reduces the relativistic effects. No extreme time dilation, no tidal waves, and no deadly gravitational gradients. It's a rocky planet with a breathable atmosphere. That implies a pressure and chemical composition suitable for humans, oxygen, nitrogen, trace gases, and a temperature range stable enough for liquid water to exist. In a world where gravity diverse time, we searched for a home, not just to survive, but to understand what it means to be. We, the children of Earth, believe that dreams can break the cold walls of science. And if these planets are only imagined, imagination itself is a spark born from science. Perhaps one day, these dreams will be the only thing that saves humanity. Interstellar was never just a movie. It was a promise, a warning, a story of a future that may be closer than we dare to believe.